the instructions for here say to find the area. So when you're just given one function, like you're given here, you're integrating that function. They give you the bounds 1 over x minus 1 dx. So now it just comes down to your comfort level with finding the antiderivative of this.
Okay.
It is a U substitution, but it doesn't have to be, because like the answer is, sorry, the antiderivative is this. Okay, but you can use a U substitution and it ends up being 1 over U du, and then the limits do change. They change from 2 to 3, but it's not really a U substitution, in my opinion. Like there's not a derivative of this to handle. So you evaluate from 3 to 4, and you get a number here, which I'm about to provide, 4 minus 1 minus natural log 3 minus 1. I remove the absolute value because it's positive. Natural log of 3 minus natural log of 2, and you could rewrite it this way if you so desired.
Okay.
Any questions on that?
No, it's easy.
It's pretty straightforward.
Yeah.
All right. Letter B here. Letter B. All right. So similarly, they give you the limits of integration. They give you the function. You don't really have to think much about it. They're not asking for like total area or net area. They're not asking for any of that. So you don't even care where it crosses, which is, kind of odd, but
Yeah.
you're just performing the mechanics of this. So that's integral x to the n dx. You add 1, you divide by the new exponent. So this is x to the 4th plus 2x evaluated from 1 to 2. If you take a derivative of this, you get back to the previous line. That's why, hence, it's the antiderivative. 2 to the 4th plus 2 times 2 minus 1 to the 4th plus 2 times 1. 16 plus 4 minus 1 plus 2. So looks like it's 19 maybe. Is the style of your exams the same? Any variance on that?
They're pretty similar.
Okay. Are they well, let's just keep going here. So the next one's somewhat interesting because they don't give you the bounds.
Okay.
And these wanted you to sketch also. Sorry, I didn't sketch any of these, but I will sketch this one because you kind of have to be able to do it. So the graph here, and I don't know how accurate you need to be, but here's the line y equals x.
Okay.
And then x squared looks like this. And it's just this little piece. It's just this little region right there.
Okay.
So more generally, though, you set the two equal to each other. And you move the x over, you move stuff over to one side, and you factor, you don't divide. So that gives you x equals 0, x minus 1 equals 0. So x equals 0, x equals 1. And you actually don't need to graph it if you've got two bounds here. You just find the area between them.
Okay.
It is top minus bottom. And if you don't remember which one is the top or which one is the bottom, you can test a point in between.
Okay.
So let's say t equals 1/2. You have 1/2 squared, which is 1/4, and you have 1/2. So which is taller? Well, it's the x. So that's how you know this is the top and this is the bottom. You wouldn't check, you do not check at the endpoints because the endpoints will give you the same value.
Okay.
If you don't put the right order, you'll get a negative answer, assuming you do everything else correctly. So you could just flip the answer, but it's better to kind of have some awareness of what you're doing.
Yeah.
All right, so this is 1/2 1 squared minus 1/3 1 cubed. When you evaluate a polynomial at 0, it's 0, so you don't have to do that. 1/2 minus 1/3 ends up being 1/6.
Okay.
There could be infinite number of variations on this type of problem we just did, or these three. There's
Yeah.
really no limit to what they can do.
Yeah.
All right, this is a calculator problem. Oh, it says that too. Because there's no known antiderivatives of this. Do
Okay.
you think you'll be given a calculator?
I probably won't.
Okay.
So.
Yeah. So there's nothing really to do here. Maybe to set up.
Okay, and just do math. Okay.
Yeah, minus 2/3 to 2/3. The x-axis really isn't important. That's what it normally is. 1 plus natural log cosine to the 4th x
Calculator.
dx.
Okay.
And you set it up, boom.
Perfect.
All right, number 4. Is that okay? Is that where we're going?
Yeah. Yeah.
Calculator, okay. All right, well, we'll set it up here again. So the graph of this ellipse, if you had to do this by hand, you would set x equal to 0. And then you would get 9y squared equals 9. So y equals plus or minus 1. And what that does is it tells you what's going on here. It tells you that when x is 0, you got 1 up here and 1 down here. When y is 0, x is plus or minus 3. It gives you this football shape.
Okay.
So how do we find the volume obtained by revolving the enclosed region closed by this about the x-axis? The truth is we only need the top portion. We don't need the bottom. So the top you get by solving for y.
Gotcha.
So that's 9 minus x squared divided by 9 square root. It is plus or minus. So the plus is the top, the minus is the bottom. If you were doing cross sections, which you kind of mentioned, you would need the top and the bottom. Like if your cross sections were squares or they were
Yeah.
semicircles,
Okay.
then you need it. If you were doing this by hand, which is impossible, you would actually want to maybe rewrite this as like 1 over x over 3 squared, because x squared over 3 squared is x squared over 9
Okay.
square root. Now, because you're revolving it around the x-axis, this is either a disk or a washer method. And it's a disk if there's, I say no gap, basically no space between you and the axis. And that is the case here. This is a disk.
Okay.
Pancake might be a better reference. Disks, I don't know if you've ever used a CD player, but there's a hole in the middle.
Yeah.
If you made pancakes, hopefully there's no hole in the middle of your pancake.
Yeah.
So you integrate from something to something. Now your lower bound is the leftmost bound. That's why we needed that point, -3 to 3 pi, and that's your radius squared. Your radius is the height, basically. So it's the square root of this 1 minus x over 3 squared dx. So this one actually works out somewhat nicely. -3 to 3, pull the pi out, 1 minus, and I'll actually go back to the x squared over 9 for the purposes of finding the antiderivative. So then x minus x cubed over 27, evaluated from -3 to 3. Then you got a pi. So 3 minus 3 cubed over 27 minus -3 minus -3 cubed over 27. So this is 3 minus 1 minus -3. This is minus 27. So it's +1 minus 2 becomes +2. Looks like it's 4 pi. And you're all done.
Okay. Cool. Not too bad.
Nope. Number 5. What is the volume of the solid by rotating about the x-axis, the region enclosed by the curve and the lines? So they're giving you everything here. You don't have to do anything. You have to use your bounds.
Okay.
You don't have to graph this. If you want to graph secant, though, as a reminder, secant is reciprocal of cosine. So it looks like that. And then it touches, so it looks like that, and then it looks like that, looks like that.
Okay.
So it's, so 0 to pi over 3 is somewhere here-ish. So once all of that. So it's pi r squared secant squared x dx. Antiderivative secant squared is tangent x.
Yep.
Evaluated from 0 to pi over 3. So a little bit of trig to remember potentially. Yeah. So maybe that's the one good thing that came out of this, is that you might need to look at your unit circle again.
Yeah.
So pi over 3 is up here. And see, I don't like, I'm trying to show you how to do this without really remembering unit circle. It's about halfway. So that's a half. That's root 3 over 2. Tangent is sine over cosine. Sine is y. Cosine is x. So that I mean, this is how you do it if you don't want to remember it.
Yeah.
And then the bottoms cancel. So you get square root of 3 or pi times the square root of 3 as your answer.
Gotcha. Okay. Perfect.
All right, up to number 6. All right, the region enclosed by the graph of y equals x squared, the line x equals 2, and the x-axis is revolved about the y-axis. This is completely different, totally different. So the graph, the picture is here is x equals 2. And then we know at 4, 2 4 on this graph. So we know it's something like that. So it's this region right here, but it's revolved around the y-axis. Oh yeah, so I like to indicate which axis you're revolving around. I think it's helpful. So there's 2 approaches here. You can either use the washer method, but then you have to do everything in the y, or you can use the shell method. And the nice thing about the shell method is when you're revolving around the y, you can actually use the x variables. They both give you the same result.
Okay.
Do you have a preference?
Let's do the washer one.
All right. So washer method, for a reminder, it's big R squared minus little r squared dx or dy. In this case, it's dy. So you actually need to solve this for x. So x equals plus or minus the square root of y. And you have to know, like, well, which one am I using? Although something about that doesn't look right. Anyway, okay, so the big R is the bigger radius, so it's always 2. Like if you were to draw a line from your axis to you can see that it's always 2. So that's 2. Your little r, though, it changes. It's 0 here, and it's 2 there, and it's something in between. It's this one. So it's the square root of y squared, like that. And then you need your bounds. So your bounds are in terms of y. So you know, oh, that's from 0 to 4. So pi integral 0 to 4. You don't care about the x direction anymore. 4 minus y dy. 4y minus 1/2 y squared, evaluated from 0 to 4 times pi. 16 minus 8 times pi, so you get 8 pi, it looks like.
Okay. Quick question. Where did the 4 come from for like the intervals?
So you're setting, you're trying to figure out this point right here where they intersect, because it keeps going. But you put 2 in there, and that gives you 4.
I just didn't plug the 2 together. Gotcha. Okay.
All right. Do you know if you're gonna get a shell or a washer method, or?
I wouldn't be surprised. I'm definitely gonna get a disc one. And I mean, I probably won't get a shell one because I don't think we talked very much about that. We maybe did like one problem, but washer is half and half. Disc is for sure.
All right.
Yeah.
This is a AP question. This is a calculator question also. What says that? But the reason you need your calculator is because you got to know the intersection of these points.
Oh, okay.
So I can just sort of like estimate where they are, but you would want to use a calculator to find them.
Yeah.
So let's just say that this is at x equals 0.5. And this one is x equals 1.5. And this is not 2, although it looks like it's, so this, we'll call this x equals 2.1. This is just Matthew making it up because he doesn't know. And the numbers really don't matter for what we're doing. But so the one thing that's interesting about this question is that they don't, well, I guess they do. They just give you, this. And they say R is this top part. Okay, great. So R, if you want to find the area of R, which I think you do, does it even say? Oh yeah, it says find the areas of R. So R is the integral from these two x values, okay, which you would have to find by going to your calculator, graphing, finding the intersection point, but I'm just arbitrarily choosing those two. And it's still top minus bottom. So it's e to the 2x minus x squared minus the bottom, which is this y equals 2. It is not asking for volume. Since it's asking for area, it's just top minus bottom. There's no squaring. And the only way to do this, there's no way to do this by hand. So it's truly a calculator problem. Now, the instructor could change it slightly to make it doable by hand, but that would require some creativity that is not here.
Yeah. Okay. So just plug that in. All right.
Yes. Yes. Now, S is slightly more complicated. S is where I think most students would struggle. So I'm actually going to re-copy this in.
Okay.
Kind of frame the question slightly different. So S is not that curve. Well, actually, now that I'm looking at this again, I guess there's 2 ways to do S. So I call this 2.1. So probably a better way to find S is it's S plus R minus R. You're like, okay, right, Matthew. Well, we just found R. Like, this is from, you know this now.
Yeah.
But S plus R, and that's actually probably how they want you to do it, is the integral from 0 to 2.1. And it's, instead of breaking this into 3 regions, which is how I think we did this whenever we looked at this a previous time.
Yeah, like studying further.
Yeah. Instead of breaking it into 3 regions, we could just find the whole region and subtract out the R.
Oh, okay.
Which I think is the better way of doing it ultimately. So your top is e to the 2x minus x squared. You subtract 2. I'm sorry, 1 this time, not 2, dx. And then you subtract out the value of R.
Okay.
And then that actually saves you from having to find. No, I guess you still need those for per day. Never mind.
Okay.
Kind of an interesting question, but purely calculator. There's no way to do this by hand. And you might reasonably ask, why would I be given something like this? And I don't know. I really don't know.
Well, if he gives me one like this, he'll give me a calculator. So
Yes.
okay.
All right. Give me just 30 seconds here just to check one thing. All right. So this question next, is that okay, or do you want something else? Okay. The company designs spinning toys. Now you're the artist. Does this look like a spinning toy, or does this look like something else to you?
It does not look like a spinning toy.
Yeah, I think it looks like a whale out of the water, but that's me.
Half is a pear, half is an avocado.
Okay, I like that.
I'm hungry. That might just be because I'm hungry. Teardrop.
So
Half a
yeah, teardrop. Yeah, we all look at things differently. So,
Yeah.
all right. So they give you a curve, and they tell you C is positive. That's important. If C is negative, I believe it flips it. Blah, blah, blah. Okay, find the area of the region, the first quadrant, bounded by the x-axis in the graph. That's so they're saying, like, look, we're making C 6, x, or C is 6. So we want you to find this. What they don't tell you, though, is this number right there. So you got to figure out where this thing equals 0.
Okay.
Which is not calculus, and it's 0 when either cx equals 0 or the square root of 4 minus x squared equals 0. Well, this one's 0 when x is 0, and that's the point there on the left.
Okay.
So this other one is 0 when x equals 2. And negative 2 for that matter, but we only care about that first one. So that's important because you need to know it goes from 0 to 2.
Okay.
Area is top minus bottom. So that's cx, but we know it's 6. 6x squared 4 minus x squared. The bottom is 0, so we just leave it out.
Gotcha.
Like that.
Okay.
Okay, now this is a better example of a U substitution. Your U is 4 minus x squared. As a reminder, your U's are denominators, roots, parentheses, stuff like that. So, and what you're looking for is that derivative in the rest of the problem, and it is.
Okay.
Now, since we're going to the trouble of using a U, we should check the bounds, or we should adjust the bounds. So that's 4 minus 0 squared, which is 4. U of 2 is 4 minus 2 squared, which is 0. And it's okay that it's 4 to 0.
Okay.
So dx is du over minus 2x. And oftentimes when the bounds switch like that, where they're like wrong, like you feel like they're wrong, there's a negative that comes out.
Okay.
So when you negate it, this negative right here will switch the bounds.
Gotcha.
So it's the
negative and the bounds are upside down, then I know I did something wrong.
I mean, not always, but
Typically in this.
yeah, it's so what you're see, they don't tell you this, but you're changing, you're like rotating the problem into another axis. Did you ever take physics?
I took it last year, but it was online.
Okay, well, let's assume you actually got this. In these block problems, they always rotate the axis.
Yeah.
Well, like there's certain situations where when you rotate it, it could be a negative rotation. Like we always think, oh, I'm rotating that way, but what if you rotate the other way? Well, it's negative. And you're not changing the domain, but it feels like you are. But when you switch the bounds, you should just double check, signs and all that. So 3u to the 1/2 du. And now we're going to evaluate in terms of u. So u to the 3/2. There would be 3/2 on the bottom, but you can multiply by the reciprocal. Okay. You can see this problem is very, very carefully chosen because of all these nice things that work out.
Yeah.
And then again, if any not just a polynomial, any rational thing, exponent thing, 0 is always 0, unless you got an e. So this is just 2 times 4 to the 3/2. If you don't have a calculator, you got to rewrite 4 as 2 squared. And then this becomes, you multiply the exponents, it becomes 2 cubed, which is 8, which is 16 when you're all done.
Okay. Okay. So you never plug in the U again.
I don't like to do that if I change the bounds.
If you change the bounds. Okay.
Yeah, because you really if you back if these got worse, like if let's just say it was like 0 plus 4 natural log of 7, I might say, yeah, let's back substitute them.
Okay. Okay. Gotcha.
Okay, part B. It is known something here. Oh, they're giving me the derivative. This value of C for the spinning toy. The radius of the largest cross-section circular slice is 1.2 inches. For what value of C? So they're giving you the derivative, which I don't know why for the moment. And they're telling you the radius of the largest cross-sectional circular slice is 1.2 inches. Like what I take that to mean, if we go back to our picture, is they're talking about this max. They're saying this distance right here is 1.2.
Okay.
And it likely corresponds. Oh, no, I know why. The derivative is 0 there.
Oh.
Why are they giving it's like, why are they giving you that? So the derivative is 0 because the original problem would be 1.2 equals cx squared 4 minus x squared. And boy, that looks hard to solve, doesn't it?
Yeah.
But if we recognize, that's why you gotta like, why are they giving this to me? Because it could be useless.
Exactly.
So the derivative is 0 though, when the numerator is 0. So the derivative is 0 when the numerator is 0. So you set c 4 minus 2x squared equal to 0. And then you solve this for x. So x 4 equals 2x squared divided by 2. X squared equals 2. So x equals the square root of 2. Where did all that go?
Okay. Would you plug in for C?
You don't, doesn't matter because this part is
Okay.
you only care if this part is 0.
Gotcha. Okay.
Okay, so that's your x value. Which, why do we care about? Okay, because now you can put this back into the original. Now I see it. So it's 1.2 equals c square root of 2, 4 minus square root of 2 squared. Oh wow, that works out nice because this is 4 minus 2 square root of 2 times the square root of 2. So it's 2c. So c equals 0.6.
Okay. So it's a simple problem. They just want you to figure out how to do it.
Yes, and I would guess that recognizing that the like this is the key word here, the largest, that means that where the derivative is 0. I would think most students wouldn't catch that because it's
Kind of tricky.
it's very nuanced there.
Okay.
Now, and especially if they didn't give you this. I mean, that would really be brutal. But I mean, this is an AP question. I mean, you're not getting questions this sophisticated for your retake, are you?
No.
Okay. All right, let me go back and grab the original thing here again.
Okay.
Actually, let me grab 2 snips. And okay, sorry. We're doing part C, which is hey, the volume is 2 pi, the volume by rotating this around the x-axis. It does say that in the prompt that it's about the x-axis. So essentially they're saying, okay, do you know how to integrate this to determine a volume? Yes, you do. This is a disk because there's no gap between it and the axis. You're revolving this way. So it's integral 0 to 2. The 2 comes from part A where we figured out, oh yeah, that's where it hits pi. And then it's the square of this thing right here, dx, because it's pi r squared. So this produces c squared x squared 4 minus x squared.
Okay.
C squared 4x squared minus x to the fourth. This is about the time I would pull this out because it's going to be useful for later on. 0 to 2, 4x squared minus x to the fourth dx. So that's 4/3 x cubed minus 1/5 x squared, evaluated from 0 to 2.
Okay.
So a lot of calculations here.
Yeah.
So what's that? 32 over 3 minus 4 over 5. And for sure, when you make a common denominator of 15, this feels wrong, but so this times 5 is 160, minus this times 3 is 12, c squared pi. And the thing that I guess I left out is the whole thing equals 2 pi. Like they're telling you, like the volume is 2 pi. Okay, so that there's that. This is 148 over 15, c squared pi equals 2 pi. Pi's cancel. You multiply by the reciprocal of this, so it's 30 over 148. C squared equals that. That's 15 over 74. So what's the square root of that? C equals square root of 15 over 74. It's very possible I made a sign error or something somewhere near this. I don't know.
Okay.
Doesn't look great, but it's the idea.
Okay. Okay.
All right, so next question here on the next page. All right, let me snip this in. All right, let R be the shaded region in the first quadrant. And they don't tell you this point here, which we should really know. So we know that's when cosine x equals sine x. That's on your unit circle. They equal right there at pi over 4.
Okay.
And you would have to know that. So the area R, which is right here, is the area between them. So R is the integral from 0 to pi over 4, because that's the intersection point. Top minus bottom, so cosine x minus sine x dx.
Gotcha.
Cosine x is, and these are antiderivative now, so minus sine x. Wait, I've got that wrong. The derivative of sine is cosine plus cosine x derivative of cosine is minus sine, a value of 0 to pi over 4. Unlike polynomials, you do really want to make sure you get all your upper and lower bounds in, because they're not always 0. Sine of 0 is, but cosine of 0 is not.
Yeah.
So that's root 2 over 2 plus root 2 over 2 minus 0 plus 1. So it's the square root of 2 minus 1. And that is positive. The square root of 2 is 1.414. So it's sort of reasonable.
Okay. Cool. Got it.
All right, part B. Part B, find the volume of the cross section. Okay. So So the only difference between this problem and is that well, there's actually a lot of difference. Let me get the graph again. So this is a washer problem,
Okay.
and it's a washer because there's a gap between the region.
Gotcha.
So if we call this big R squared is cosine squared x, and then little r is the other one. It's sine squared x. So it's top minus bottom. So it's the integral from 0 to pi over 4 again, pi, and then cosine squared x minus sine squared x, like that, dx. The only way to do this problem from here is to remember some Pythagorean identities,
Okay.
which feels really out of scope.
Yeah.
Let me go look. So the one that comes to mind is that you can make one into the other. So like cosine squared is 1 minus sine squared x. So this becomes 1 minus 2 sine squared x. And then what I was referring to, those are Pythagorean identities, is double angle forms. Oh, this is a double angle. Now I see why they're doing this. So see this last one here?
Yeah.
Of the 3 cosine. So cosine 2x equals 1 minus 2 sine squared x, which is exactly what you have here. So it's pi integral 0 to pi over 4 cosine 2x dx, which is, I mean, I don't know. Do you think that's reasonable, or is that just like?
It's a little much, but you never know.
Yeah.
You could throw anything at you.
So, you know, you got to know all of your trig from previous years.
Yeah.
Antiderivative cosine, so we got 1/2 sine 2x. The 1/2 comes from the derivative of this.
Okay.
And so it's pi 1/2 sine 2 times pi over 4. Sine is 0, 0. So this is pi over 2, which is 1. So this all just becomes 1/2 pi.
Okay.
Part C. Part C. Find the volume of the solids whose bases are and whose cross sections cut by planes perpendicular to the x-axis are squares. So I take that to mean like this is a square, is what they're saying.
Okay.
And the square, it's like side length is cosine x minus sine x. And since it's a square, so is the other. So the area is cosine x minus sine x times itself, which is this.
Okay.
I'll stop using red here. It's a negative color. So if you were to multiply this out, you'd cosine squared x minus 2 cosine x sine x plus sine squared x, which is different than the previous one.
Mhm.
And the reason that matters is because you integrate for volumes, you integrate the a. It's a of x dx. So it's there's no pi. You're not like it's squared because it's the area of a square, but it's this thing right here. But these right here, this is 1.
Okay.
And this is another one. This is a double angle formula. It's 2 sine of 2x. You know, if you don't remember that, you can use a U substitution for this part, but I think it was designed this way based on the previous one.
Okay.
if you take calculus 2, you do a lot of this type of trig stuff in there.
Okay.
Cosine 2x divided by 2 pi over 4 plus cosine pi over 2 minus 0 plus cosine of 0 over 2. Cosine pi over 2 is 0, so this whole thing is 0. Cosine of 0 is 1, so it looks like it's pi over 4 minus 1.
Okay. Gotcha.
Is there anything else you would like to look at today?
No, I think that's it. Those are the problems.
All right. Well, do we have another session tomorrow or next day?
We have one tomorrow.
All right.
It should be
Great.
the last one.
Well, I appreciate you scheduling, and I'm glad to help. I'll send you the notes here shortly, and good luck on your test.
Thank you. See you later.
Have a great night. Bye now.